Hello, today I'd like to talk to you about chemical food preservation. Specifically, I would like to talk to you about enzymes found in food. In order to do that, we need to talk about what enzymes are. Enzymes are proteins built by cells that allow reactions to take place. Specifically, they allow for a standard reaction to go ahead and react faster. This is called a catalytic reaction. There are thousands of enzymes, and each enzyme goes ahead and reacts to a very specific substrate. The one that we're going to talk about with food today is polyphenol oxidase. Now, polyphenol oxidase is found in many different fruits and vegetables. If we look at the diagram we have on screen, you will see that there is an enzyme, an active site, and a substrate. Let's imagine for a moment that our enzyme is found in our food and that our active site is attached to the enzyme in our food. Let's then go ahead and imagine for a moment that our substrate is the air around that food. So imagine, if you will, an apple or a banana. If you bite into an apple or a banana, you then let it sit on your counter for a moment and then come back to it later, you'll notice that brown pigments have actually formed. And that's essentially what happens here. So if we take our enzyme and our active site, and they're sitting in our apple or our banana, and we grab our substrate, which is our air, specifically the oxygen in the air, we let these items come together, they will eventually form a product quite quickly, and that product will then go ahead and be brown pigments. Now, you may think that this might be an annoying reaction, and at times it can be, and in others it's not. So then there might be some good ways to go ahead and help control or prevent this reaction from occurring. When we say this, we mean to go ahead and inactivate our enzyme or stop our enzyme from working. There are several different ways that you can go ahead and do this, but the ones that I'm going to focus on today are going to be heat. I could also utilize pressure, or I could also utilize pH adjustment as well. Now, if I use pH adjustment, I would have to go ahead and lower the pH and make it very acidic, or raise the pH and make it very, very basic. Our experiment will go ahead and use heat today. So what we're going to specifically look at is potatoes. What we want to go ahead and do is measure the shape, color, and texture that changes as we go ahead and use our potatoes. So I'm going to give you a little bit of back history here. We're going to take regular potatoes, raw potatoes, and we're going to go ahead and compare them to deep fried potatoes. Now, to deep fry potato, it's very simple. You'll take the potato, slice it very thin, place it in oil that's at least 300 degrees Fahrenheit or more, maybe closer to 325. You'll let it sit there until it stops bubbling and moving. You'll then pull it out and allow the excess oil to drain off of it. The interesting thing about making a potato chip is the heat is actually so high that the enzyme involved, or the polyphenol oxidase, never gets a chance to go ahead and actually react. The temperature that an enzyme is going to go ahead and die at in this case, or inactivate in this case, is about 115 to 120 degrees. And since our oil is at least 300 degrees, we don't really need to worry about that reaction taking place. We just need to make sure that we are fast enough at slicing our potato and then going ahead and getting it into the oil. Now, if you look over here, I have three different examples of food. The first one I have is a potato, and you'll notice that we have some brown pigment sitting right here. And then I have my potato chip back here. Now, the interesting thing is, if I actually take my potato and I look at it, and you see the brown pigments, if I actually cut the potato open and I compare the brown pigments that way, you can see how this is still very, very white and not oxidized, and how this has gone through and colored. Now, this has been sitting here for about 20 to 25 minutes, and this is the amount of color that has occurred. If I then go ahead and compare this to my potato chip, you can see how the color of the potato chip is much, much closer to the unoxidized potato than it is to the actual potato that has gone through an oxidation. If I then go ahead and come over here, I have bananas and apples. If I look at my banana first, you'll notice that there are brown pigments on the peel, there are brown pigments on the banana itself, and if I actually pull the banana away and I pull back, you'll notice that all back here, there are no brown pigments at all. But if I turn it this way, you can actually compare. So this hasn't really been around the air. This has, and again, it's been about 20 to 25 minutes. I can do the exact same thing with my 3 apple slices here. Now, it's kind of hard to tell, but there are little dots of brown pigments all over these 3. If I cut an apple and I actually compare it to what that apple actually is supposed to look like, you'll notice that the apple itself that I just cut doesn't really have a lot of color going on, but if I compare it to these 3 right here, you can see that there are a lot more brown pigments. Thank you. This is the end of my enzyme reaction.